The first speaker that we have today is Pierre Fernique. Pierre is the technical director at the CDS in Strasbourg in France, very involved in interoperability topics within the IDOA. And his talk is going to be exactly about data interoperability and the experience at the CDS.
I'm Pierre Fernique, and as Fabio said, I'm working at the Centre de Données Astronomiques de Strasbourg. And first, I would like to thank the organizers for inviting me to speak on this topic of data interoperability. So, well, what is interoperability? I propose these two definitions, one from a user point of view and the other from on the net. My colleague, astronomers, say interoperability is what allows different applications to work as one. But behind, we see that we have to exchange data, understand the data, and finally consume the data. And it is an interesting definition, but I'm not sure that you're really expecting a course. And in fact, interoperability is really a recurring topic. And I had fun counting the number of papers talking about this since the beginning of ADASS in 1992. And there were more than 150 articles on this topic. And I think this is by far the winning topic of your concerns. So what more can I say? And in fact, I have been working at CDS for about 25 years now, and behind my own experience, CDS is really a good vintage, I would say, almost 50 years old. So I'm going to suggest that we explore together the different interoperability solutions that have marked the evolution of CDS, those that worked, those that did not, and in short, use the CDS experience to explore again this recurring topic. And I will follow this, this plan without surprise, why exchange data, with whom, which data is concerned, and how to distribute them. But as I will base my presentation on the CDS experience, I have to present briefly this data center. The Strasbourg Astronomical Data Center can be summarized using these four numbers, 3, 500, 16, and 2 millions. Those three well-known services, Simbad for objects in literature, VZ for tables and catalogues, and Aladdin for images. And it represents 500 terabytes of data, 16 operational servers or websites spread over the 5 continents, and more than 2 million requests per day. That means more or less 5,000 since I just started this presentation. So I would say that interoperability is a constant reality for us. And let's start with the first point: why exchange data? The base of the problem. And in the context of CDS, it is interesting to come back to the origin of its charter: collect useful data on astronomical objects in electronic form, 50 years ago, improve them, distribute the results to the international community. And it is interesting to note that in 1972, these concepts are already very close to what is understood today by the FAIR principle that we have presented several times during this conference and before. In fact, it is interesting to note that how astronomy has been a discipline particularly favorable to this exchange. First of all, we have a long tradition of collaboration. Of course, the need for scientific exchange provides a favorable context, but probably not sufficient. And in a very concrete way, it may be due to the significant cost of the instruments versus the strategy factor of this equipment. And if we compare with other disciplines such as biology or earth science, the financial or strategic issues are such that collaboration, even scientific, may be less easy. Simply the fact that astronomical data has no real market intrinsically, market value, I mean, makes this data much easier to give. And concretely, we are in a very favorable win-win situation for interoperability solution. Well, a favorable situation, but with room to exchange our data. And if we take the example of CDS, but no doubt that is also true for other data centers and archives around the world, we exchange data not only between the various servers for which we are responsible, but also with dozens of other institutes, your institute, publisher, other data center, in order to enrich their data and our data. It is a form of reciprocity, which means that, for example, ADASS collects all the SIMBAD content it needs every week, and we collect articles from major publishers daily in order to update our databases. And in addition, we must also take into account the thousands of clients who access our databases directly, Aladdin, Stellarium, your web interfaces which require an astronomical position, etc. So all this put together, we find our 2 million requests per day. Now, we come to the question of what kind of data to exchange. And our answer has always been the same during these 50 years, everything that is technically possible. But we will see that it has evolved in time. And until the 90s, we only provide database records, the SIMBAD content. Then at that time, the evolution of the technologies, and mainly internet, allow the distribution of astronomical tables and catalogues. And it is VISI. And we had to wait another 10 years to be able to exchange the origin of all this data. I mean, the pixels, the images. And you have ADASS. So at first glance, one might think that it was the volume that was the discriminating factor. But in fact, the real answer is not so simple. Yes, the network is constantly improving, but the data is also growing larger. And if we compare the growth factors, we realize that the network effectively multiplies its performance by 10 every decade, but faced to a 30 factor for the size of the image. And very concretely, we were certainly in a more favorable situation in 2000 when we had to exchange 2 mass images than now when we try to download mega prime images. And I'm not talking about LST images. Also a point to underline is that a large fraction of the traffic, of the world traffic, is now done on mobile devices. And it's not really a very fast technology. And today, half of the humanity has less than 9 megabits per second. So therefore, the answer is not the volume in an absolute way, but the time necessary to move from a point A to a point B, such or such data. So when the data is too big, and obviously it is always too big for some things, we are, and you have several solutions, mainly 2. Either we offer our user to operate directly on the server, and only the final result on the request will be transmitted. And for example, until 2006, we had an email query submission service for SIMBAD. And nowadays, we are implementing Jupyter Hub on various sites to dynamically perform remote tasks without having to move the data. And if we take a step back, we can see that it is quite similar to our old Unix accounts that we offered on our servers to our users in 90s. Python to replace the shell, the browser panel instead of the VT console, but basically it is the same solution. Get the job done without moving data. And the second solution, which can be seen as complementary to the first, it consists in moving only the data strictly necessary for the user needs. It is a principle that you can find in the AVR TAP protocol or in the HIP system. In the hierarchical progressive survey mechanism, the data, the pixel, the source from catalogues, is split into tiles, and only tiles necessary for the user will be downloaded. And if we look, using statistics of HIPs, this is clearly the most successful approach. Pre-calculate the data the user wants, but obviously it's not always possible. It depends the cases. To finish on this point, I will present here the evolution of the statistics of the usage of SIMBAD over 25 years. We went to 50 queries per day in 1995, and today close to 700,000 requests per day. Wow. It is interesting to note that our ability to respond quickly to user requests will create new uses, new clients, new usages. And I will try to illustrate these things with the rest of my presentation. Okay. I have been talking about data so far, but data is useless if we do not know what it represents. We come back to the definition of my first slide. And first and foremost, data interoperability requires good metadata. If we look the composition of our team, we are 40, and I would say that almost 70%, maybe less, maybe more, of the work that these people do is to associate the right metadata with the data we have to exchange. It's our job, our added value. So what do I mean with metadata? These are the 4 Ks of the interoperability: to name, to describe, to characterize, and finally to measure the data. And I am going to dwell a bit on each of these points, but just before, I will illustrate why it is necessary to do this. I display here the widget that you can install in any of your web pages. It draws the energy distribution from all the 20,000 tables that Vizier contains. You give a position, and the system is able to plot on the same graph the values in flux versus wavelength from the column of these tables. So to generate this graph, it was necessary to select before the right tables, the right columns, the right units, and to associate the right systems, typically filter definitions, and finally to combine them in this graph. So maybe a day an IA will be able to do this automatically, but right now it's still requiring a big part of human expertise, the brain. So now let's start with the identification of the data. We mainly use 4 systems at CDS: the bytecode for bibliographic reference, the catalog identifier, the DOI, and finally the IVORs. The goal is to be able to list the data resources in a databases, in a registry. If you do not have a robust identification system, interoperability becomes really much more difficult. And I would like to draw your attention on one of these characteristics that is sometimes a cause for concerns. It's the ability to create an identifier even before publication. It seems obvious, but depending on the mechanism, it's not always possible. And typically the bytecode as a paper of the publication, or the IVON needs a pre-declaration in the VO registry. So it's better if this problem does not exist. One step more, the selections. The data we handle is diverse, and it is often impossible to describe each distinct data item. This is why it is necessary to choose the data elements which will be precisely described. So for example, in Vizier, we will first characterize the column of positions times, and flux. And in the same way, for Simbad, we will determine in the set of research articles the citations of astronomical objects. And this is the heart of our work. Select the good data to be able to provide the good metadata. And of course, this step is very time consuming. And even if we have tools to help us to do that, expertise remains the main criterion to get interesting interoperable data. And finally, to characterize this selected data, we use several methods. The most complete consists in being able to associate a reference system and a unit. It allows numerical comparison, but this step is very expensive in terms of expertise. This is why we explore a complementary way allowing to associate to less important data a description a little bit fuzzy of what it represents. It is a magnitude, an error, a parallax. These are called UCDs, and this characterization mechanism has been deployed for about 15 years, and it works very well. And for instance, the Vizier catalog selection system can be used by UCDs. But in fact, it is used relatively less than we would have hoped. And it is probably due to the inherent imprecision of UCDs. Maybe it generates too much noise. Or maybe because users do not fully catch what it represents. So, well, now I come to the structuring of the data to be exchanged. There are two approaches. Either we can deliver the data as it was produced, and that's typically the approach of a platform like Zenodo. Or we can map the data into our own structure. And this is the approach adopted by CDS, mainly because it allows to manipulate a small and well-defined set of metadata. And the clients who will have to read this data will only have to support one single structure. So, to provide consistent and homogeneous data and metadata, we have hoped for constraint structures, predefined field for Simbad, a two-level structure for the catalogues, and a tiling system for Aladdin. And now, my last point of my plan, how to distribute this data. There are 5 choices to decide. The first 2 have obvious answers. Internet and HTTP are currently unavoidable. The other 3 choices are less obvious. The packaging, how you move the data into the pipe, the request protocol, and at the end of the pipe, the clients. So let's study these 3 elements. When it is necessary to transport data, either it is the packaging that adapts to the data, or it is the data that adapts to the packaging. And the choice of CDS is more oriented toward the second option, because very concretely, it allows much greater flexibility. And again, it is much simpler for the clients. Have a look on 2 packaging, HDF5 and HIPS. In fact, you will find very few clients capable of reading HDF5, or more exactly, to understand the correct HDF5 dialect. I cut this article explaining that this schema of HDF5 is not good for our purpose. HDF fits not, and I will create a new one. I'm not denigrating at all the intrinsic quality of HDF5. I'm just saying that this approach, packaging adapted to the data, is at the end more complex for clients. In contrast, we will find more than 15 different clients for the HIPS packaging mechanisms by tile, and more than 20 data providers of HIPS styles. And this protocol has been standardized in 2017. So just 3 years ago. So clearly the second approach is probably more interoperable. It's my point of view. Okay. as I said just before, data without metadata is not very useful. But how do you transfer this metadata? The most practical technique is logically to use the same mechanism for both. It allows them to be closely associated.
Pierre, five minutes.
Okay. Surprisingly, this is not always the first choice of users. For example, there are a large fraction of VZ users who continue to download their catalogues in ASCII with almost no associated metadata. Anyway, there are three possibilities to transfer metadata. Either a free vocabulary, for example, fixed keywords, and this method quickly turns out to be limited by the impossibility for the clients to effectively process this free vocabulary. It is very heterogeneous, and how to do something with them. A more pragmatic solution, which is mainly the one used at CDS, consists in using a control vocabulary and dedicated fields. And we will find this in, for example, in VO table formats results. But the more comprehensive approach will be to provide the data model associated with the data with two variants, predefined data model or self-describing data model. But this last approach is also tempting, turn out to be very difficult in practice because it requires prior agreement on the data model and the evolution of this data model. And in an international multi-partner context, notably in ADOA, this is clearly a challenge. So, data distribution requires a request protocol. We can only applaud the efforts of the ADOA to standardize this kind of protocol. This is clearly the best approach for interoperability. Even it is not always well adapted to the specific needs. You can deploy local solution or bypass solution, but in terms of interoperability, it is not the same impact. Or even you can choose proprietary solutions, even open, but you will see that the control is totally out of your hands. And you have absolutely no guarantee of sustainability. So at the end of the pipe, you have the API and the client. And this is what you are using to interact with our servers. And as we relied on open standardized protocols, we have seen the deployment of a wide choice of clients and API developed by ourselves or others dedicated to several types of audience, scientists, amateurs, general publics. And as I said, the diversity, this diversity is really a good indicator of the interoperability of a system. And we are closely monitoring the evolution of this access mode. At present, it is now more than 80% of requests which are not at the end of the chain, but which come from third-party tools or partners institutes in order to re-ingest our data in their databases and combine them with their data. And we also measure that our audience, I mean the number of different IPs, for a very large part, 60%, come from general public tools now, and especially Stellarium. And if we have in mind the Simbad evolution usage at the beginning of my talk, we see that the world evolves, the technology evolves, and so the usage evolves, and we have to follow this evolution.
Pierre, 2 minutes.
So my last slide, in fact. I go back to the initial question, why exchange data? And I admit that when I was preparing this talk, I wondered about the evolution of the astronomical context. And in fact, astronomical data, which only now has no monetizable value, is now paying indirectly, whether through marketplaces, dedicated apps, associated advertisements, or the personal data collected by various platforms. And we are seeing the emergence of new practice, in fact. And therefore, will the win-win bet of the data sharing is always true? And what are the counterparts at any level for the country level, taxes? And very concretely, at our level, how we will continue to be funded if anyone can download and redistribute Simbad in a way similar that to what is done on Wikipedia content. And it is an open question. And another big evolution concerns the rise of interdisciplinarity. For instance, the European projects, ADA or EOSC, are working on sharing data with more disciplines than just astronomy, with social science, medical science, etc. Will we collectively succeed in expanding or inventing new structures such as AVR to cover this new field of interoperability? It's an exciting challenge. So I have quickly presented 50 years of CDS experience on interoperability, at least my feedback. And this was not an absolute truth. Things are probably more gray than black and white as I have presented. And I will let you make up your own mind. And to finish, I would like to end my presentation by thanking all the people and my colleagues and our predecessors who have built these interoperable systems at CDS, of course, but also you, partners, data centers, archives, publishers, developers, the VO, and finally, all the actors of the internet, which allows this interoperability to be a reality. And thanks for your attention. I finished my talk. Question?
Well, before letting questions from the audience, I will take the privilege of sharing this session by asking my own one.
Okay.
You mentioned that there is a lot at the beginning, that there is a lot of human work for describing data, for generate the metadata and so on and so forth. Could you comment about the possibility or you're already using artificial intelligence to actually do that, to ease, because the data are going to be more and more in time, and so doing things by hand is of course very important to curate the data, but also very consuming in terms of how people work.
In fact, we are trying to help all the people in CDS by tools, by different solutions in order to simplify this task. I will say that it's difficult to know if a technical solution, AI or equivalent engines, will fully replace the human expertise. It could help. And if you look, the AR topic is a recurring subject, probably as old as interoperability. We have tried to replace some part of our tools, notably with an AI to retrieve the identifier in the papers, and the result is good. Not so far that the human results, but in fact, we come back to a solution that we have a better control and based on regular expression. So we always try to help the metadata and the selection of data by tools, AI or a neural network or whatever. But at the end, if you want to have a good metadata and good selection, human expertise still be necessary in my experience. But maybe it will be evolved, and we have seen very good progress in AI. But just it's a kind of joke, but if I look at AI providing to me so many advertisement pop-up and videos normally associated to my profile, well, I think the computation cost for such bad results, well, leaves me a little bit doubtful, but well, it depends of the subjects.
Thank you, Pierre. I don't see any other question in the box over here. So if the members of the panel have some questions to ask verbally. Oh, sorry. Great. Gabriel is asking that CDS would recommend the use of VO table, but TopCat recommends the FITS format for very large table. how to reconcile?
Both are good, and typically both in the category of a pivot standard. You have metadata, enough metadata. It's quite similar solution. VO table is generally richer in the metadata. You have more description. The fixed keywords can be sometimes too flexible, but after that, it depends of your purpose. If you need a very fast access to the data, fits is probably better, and sure. But in VO table, you have some variants providing the metadata in ASCII and the data in binary. It depends, but both are good, definitely.
Okay, so let's thank Pierre again.